Hello everybody and welcome to our third dynamics video. I think, yeah, it looks like our third. We are looking today at force of friction. So up until this point we've done Newton's laws, we looked at force of gravity, we talked about what forces actually are, and we talked about free body diagrams. And today we are going to be exploring the world of forces a little bit further. So everybody's heard of friction before, but probably have never done any math with it or physics. So today we are going to do that. Friction is created whenever two surfaces move past one another. So if you're sliding your book across your desk, there's the surface of your book and the surface of the desk, and you're sliding them across each other, and there is friction there. And it is slowing down. It is opposing the motion. So friction opposes motion. There are some exceptions, or maybe not exceptions, but there are some outliers to that. But in this class, with the basic physics problems we're doing, friction will always oppose motion. So basically, friction happens because on a microscopic level, on a tiny, tiny level, if we zoom really, really far in, there are irregularities. So the irregularities in the two surfaces catch on one another. So if you think about your book on a table, you might draw it like this, right? There's your book on a table. You're going to slide it across. But if we zoom in really, really, really far to a microscopic level, the surface of the book is going to be irregular. It's going to be bumpy. And the surface of the table is also going to be bumpy. So when you're trying to push the book this way, it's all these little bumps are catching on each other, and that's what creates that friction force opposing it. It's harder to push that it makes it harder to push that book across the table. Our table and our book are both pretty smooth, but we know if we were trying to push that book across sandpaper, for example, then maybe there was a big sheet of sandpaper on the table. It's going to be a lot harder to push, or it'll require more force to push that. So let's look at the formula. Force of friction. Force of friction is equal to mu multiplied by normal force. So that's our formula. FF is force of friction. And that is in newtons. Mu is an interesting one. This is also called the coefficient of friction. And it actually depends on the surfaces. So like I said, sandpaper is going to have a higher coefficient of friction than the table, because the table in the classroom anyways, because it's got a rougher surface, right? So that has a higher coefficient of friction. This is pronounced, if you want, as mu. It is a Greek letter. It's like a U with a front tail. That's the way I always think of it. So you'll either be told that or you'll be solving for that. And Fn, we know, is the normal force. And the normal force is always perpendicular onto the surface. And generally, that is, we see a lot of normal force is equal to force of gravity. Because if we looked at this book, the normal force is happening because there's a force of gravity pulling down on that book. So that's your force of friction formula. I want to talk a little bit about static friction and kinetic friction. We aren't going to use that a ton, but you might see those words come up. So static versus kinetic. Basically, static means stationary or not moving, and kinetic is moving or motion. So there is static friction and kinetic friction. So if you think if you had a ramp, and you put a book on that ramp, well, if the ramp isn't very steep, the book isn't going to slide, and that's because the static friction is got enough force to overcome the force of gravity trying to pull that book down the ramp. Let's maybe draw this. You've got a block on the ramp. Well, when it's not that steep, if the force of static friction is big enough to stop the force of gravity going down, we'll probably get into some ramp problems. So that's not exactly how gravity works, but just for this thought experiment, it's a little bit nicer. So if the static friction is large enough that it can fight against the force of gravity, that book isn't going to move. But if I were to make it really, really steep, we know that the gravity is going to be a lot bigger, and that force of static friction won't be able to fight that, and the book will slide. Kinetic friction is kind of more of our common friction problems, right? Something being pushed across a surface, and that is the coefficient, or that is the friction happening when something is moving. So in that example of the book, we're going from static friction, and then we're looking at kinetic friction because the book is now moving. And there actually is a difference. The static friction is bigger, is larger than kinetic. And that's the same with the mu. So there's actually sometimes two different coefficients of friction, and the static one is always a little bit bigger than the kinetic one. So what I always like to think of when I think of this, when I think of static and kinetic friction, I always think of moving couches around. When I was younger, in my mom's basement, we used to move all the couches around in the room so that we could make, like a place to play hockey, or build forts or something. And I don't know if you remember, as a kid, it actually is a lot harder or it takes more work to get the couch moving. Once the couch is moving, you can kind of march it across the room and it's not so bad. And that's because the static friction is a little bit higher than the kinetic friction. So you have to really push to get it moving, but once it's moving, you can kind of just maintain that pace. And that is the static and kinetic friction. And that's what my mind always thinks about. But anyways, let's jump into a practice problem. Here we have a 3.75, a 3.75 kilogram block is pushed along a tabletop with a force of 45 newtons. The coefficient of friction is 0.6 seconds. It says here, find the force of friction and find the acceleration. So the first thing we want to do is, maybe I'll zoom out a little bit so we have some space. We're going to draw a free body diagram. So we have our block. I always draw it right underneath the letters. We have our block. It's being pushed along a tabletop. So that's a force applied, and that is 45 newtons. We see here that there's friction, right? It's telling us there's a coefficient of friction, and we are finding the force of friction. Friction always opposes the motion, so we have force of friction going this way. The block has a mass, therefore it has a force of gravity, and it's sitting on the surface of a table, and it's not actually moving in a vertical direction. Therefore, we have an opposing normal force. There's all the forces there that's acting on our block. So A says find the force of friction. So let's do that. Force of friction is equal to mu multiplied by normal force. Well, we know that mu is 0.65, mass is 3.75 kilograms, and force applied is 45 newtons. That's what we know. We're looking for force of friction and eventually acceleration. So my force of friction formula is Ff is equal to mu multiplied by normal force, but we don't actually know the normal force. So there is no net force acting in. So this is mathematically what happens. If we're just looking vertically, let's ignore the horizontal forces. If we're just looking vertically, there is zero net force. And we know the net force is Fn plus Fg is equal to 0. Well, that means that if this one's negative, that means that Fn is going to equal Fg. That's where that comes from, right? There's no net force, then those forces must be equal. So in this case, we can say, well, I don't know the normal force, but I do know that I can substitute that with Fg. And I know that Fg is equal to mass times gravity. So now I have an equation here. Force of friction is equal to mu multiplied by mass multiplied by g, which is a constant. So I know that, I know that, I know that, and I can just calculate. Mu is 0.65, mass is 3.75 kilograms. Mu is unitless, by the way. I totally forgot to mention that. Let's scroll up. Mu is unitless. It doesn't have a unit. So 0.65 multiplied by 3.75 kilograms, and g is 9.81 meters per second squared. So we type all of that into our handy dandy calculator, and we get 23.9 newtons. That's our force of friction. We know that it's acting against the motion. So if we say this is positive, this is negative, we can also say that force of friction is negative 23.9. That also comes from right in there. If we made that negative, because that's going downwards, then it would be, we would get that negative. But again, direction's an interesting thing because mathematically it will always work out. But if you have the brain to say, okay, well, it's opposing motion or it's going in the negative direction, you don't really have to worry about it till the end. And then you can say it's negative 23 because it's going the opposite direction. So that's the answer to A. B says, find the acceleration. Well, so now we can do B. So let's have a look at our free body diagram. So we're trying to find acceleration. This is the formula that we have that has acceleration in it. Has mass times acceleration. So if we're just looking at horizontal forces, because forces that are perpendicular don't act on each other, we know that the net force is going to be force applied plus force of friction is equal to mass times acceleration. And then we can divide out mass from both sides. And we have acceleration is equal to force applied plus force of friction all over mass, and we can solve that. So force applied was 45 newtons plus force of friction is negative 23.9 newtons. It's important that you make that negative. It is going the opposite direction. And then your mass was 3.75 kilograms. So in this case, we can punch that into our calculator. 45 minus 23.9 all divided by 3.75, and we get an acceleration of 5.6 meters per second squared. So again, if we talked a little bit in Newton's second law video about unbalanced forces result in an acceleration, and you can see here that if force of friction was 23.9 newtons, then we have an unbalanced force. We have 45 newtons going this way, negative 23.9 newtons going the other way. Unbalanced force means there's an acceleration in that direction with the larger force. That's it for friction. Thank you for watching. Don't forget to like and subscribe.